All right, so here's number 4. The Great Pyramid of Giza in Egypt is a right pyramid with square base. The pyramid is made of solid stone. The sides of the base are 230 meters long. Diagram below represents the pyramid label VABCD. V is the vertex of the pyramid. O is the center of the base. ABCD here. Of the base ABCD, and then M is the midpoint of AB. So we know that this is going to be the same as that. And then ABV, A to B to V here is 58.3 degrees. Okay, so first thing, show that the length of VM is 186 meters. So note that when it says show, you actually have to show your steps. That's what they're going to look for. They're not going to look for you coming up with 186. They want to know how you came up with 186. Okay, so if we're going to show here that VM is 186, we know that, we know that MB here is half of 230. So MB equals 230 over 2, which is going to be what, 115? Okay, so we know that this is 115 meters. Let's see, and we're V to M. So what we can do here is we can actually use this triangle right here, because this right here will be a right angle. So we got MB and V. So let's just kind of redraw that. You know what? I can make a nice looking triangle. Let's do that. There we go. So there's that, and then we've got, make ourselves a nice little spot over there. Look at that. That's a pretty looking triangle. All right, so this is M, this is B, and this is V, right? So we know that this is 58.3 degrees, and we know that this is 115. So then we're trying to figure out what VM is right here. So here's kind of a good idea on a lot of these. Instead of putting X for that missing side, let's put, excuse me, VM, because that's what we are looking for. They want us, when we are done, we should say VM equals instead of X equals. Okay, so with this, we've got a right triangle. We're looking for the opposite side, and we have the adjacent side. Okay, so opposite and adjacent with good old SOHCAHTOA is going to be tangent. So on this one here, so for A, we're going to do tangent of the angle, 58.3, equals opposite, which in this case is VM, over adjacent, which is 115. All right, so we're trying to get VM by itself. So we are going to multiply both sides by 115 to get rid of the 115 there. So this is by 115 as well. That's 115 times tangent 58.3. And we just crank that out on our calculator. All right, so we've got 115 tangent of 58.3. And that gives us 186.2. 186.2, which really to 3 significant digits is 186 meters, and that's what it says it's supposed to be. VM is 186. So this is the, it would probably be a good idea. You don't have to show your triangle, I don't think, but this here you definitely want to show, right? And then we get that VM equals 186 meters. Okay. B, calculate the height of the pyramid. So again, nice thing about a lot of these problems here is they kind of lead you from one thing into the next. Like oftentimes what you did in A, you're going to need for B, and what you need in B, you're going to need in C. So this is true in this case. So the height of the pyramid VO. So now we've got VO, and look, we know that OM is half of 2. We should know that that's half of 230, and we just figured out that MV here is did I say M? Oh, VM, MB, MV, not MB. MV we just figured out as a, well, we knew that, oh no, that was right over here, sorry. This, there we go, MV is 186, MB is 115, we're good. Don't mind me. Okay, so we can figure out what that height is there. So let's draw ourselves yet another triangle. So let's go V to M to O. So here's our, let's call that the VO. So this is V here, this is O here, and then we got this M that goes off this way. Right, there's M, and then we can do that, make ourselves a nice little right triangle. We're trying to figure out what this VO side is. We know, since this is right in the middle of the square base, we know that that's going to be halfway all the way across, so that's going to also be 115. And we know that this, we just figured out that this here is 186, right? And since we rounded this thing off, it's probably going to be best for us to have this as 186.2 when we're trying to figure out this other side. Hopefully it won't make a difference, but it is a good idea to use the unrounded number to figure out that last side. So a squared, b squared, c squared, right? So a squared plus b squared equals c squared. Whenever you have two sides of a right triangle and trying to figure out the third, always Pythagorean theorem, right? So let's do, a we'll say is VO squared, b can be 115, and then the c, remember, is always across from the right angle. So in this case, it's going to be the 186.2. Right, so we're going to square, oops, we're going to square that as well. All right, so, excuse me, 115 squared gives us 13,225. So we got VO squared plus 13,225 equals, and then we got, let's just leave that in there, 186.2 squared. Is 34,670.44. Right. So to figure out what VO is, we got to subtract the 13,225 from both sides, and we get VO squared is, let's see, so we got that, and we're going to subtract the 13,225. Excuse me, we get 21, I already forgot, 21445.44. And then to get rid of that square, we square root both sides, right, to get rid of that, and we get that side VO, excuse me, we square root our answer, and we get enter, and we get 146.44. So again, to the nearest, we do three significant figures. So VO is going to equal 146 meters is VO. Okay. Okay. Let's see, there's our first answer. That's the answer for A. So then part C says find the volume of the pyramid. Now you're going to want to use your volume of a pyramid, excuse me, which is going to be 1, you can find that on your formula sheet, should be 1/3 the area of the base. So that's going to be, in this case, 230 times 230 times the height, which we just found out in B, which is 146, right? So we just want to throw that into our calculator, and away we go. So 1 divided by 3. It's better to put 1 divided by 3 instead of like 0.33 or 0.333. You want to get as many decimals out there as you can and then round at the very end. So 1 divided by 3 multiplied by 230 and 230 again for the area of the base, and then times the height is 146, and that gives us a big a large amount of volume here. So that's 2,574,000. So if we're rounding to the nearest, 140. We should do 146.44. I bet you that's going to change our answer a little bit. Let's do that. So we can go back to this. Let's see. That did not help. Let's just start over. So we got 1 divided by 3 times 230 times 230 times 146.44. Let's use that. Just in case. Yeah, look, that gives us 258 instead, which I bet you that's going to be our correct answer. So 2,580,000, and this is going to be cubic meters. That is big. Right? 1, 2, 3, 4, 5, 6. Yep, 2,580,000 to 3 significant digits. Okay? So that is C. Part D, write down your answer to part C in the form A times 10 to the K, where 1 is less than or equal to A, less than 10, and K is an element of the integers. This big mess of stuff right here is IB secret code for scientific notation. Right? Because basically you see this, you see like the key, really kind of the key in there is you see 10 to some number, and you're like, oh, that's just scientific notation. And this is just saying that your A has to be between 1 and 10. Basically, it's got to be a single digit before the decimal that's not 0, and then it's got to be, and then this K here has to be some kind of integer, like 1, 2, 3, 4, 5, 6, -1, -2, -3. So this here in scientific notation is going to be 2.58. And we would really move the decimal is here, so we have to move back 1, 2, 3, 4, 5, 6 spots to get it to 2.58. So it's times 10 to the, since we took a big number and we made it smaller, to make up for that, we have to make this a big number. So this has got to be 10 to the positive 6th. All right, so that should be our answer for D. All right, and then there's our C answer. And then let's take a look at E, which is a little farther down here. Okay. Ahmad is a tour guide at the Great Pyramid of Giza. He claims that the amount of stone used to build the pyramid could build a wall 5 meters high and 1 meter wide, stretching from Paris to Amsterdam, which is 430 kilometers apart. Determine whether Ahmad's claim is correct. So, what we have the volume of this pyramid. We just want to figure out what the volume of this wall from Paris to Amsterdam would be. Okay, so this is all in square meters. That's 5 meters. That's 1 meter, and this is 430 kilometers. So let's turn that into meters. So we got 430, and if you remember our conversion, King Henry died unexpectedly drinking chocolate milk, right? So we are kilometers, which is this one. We want to go over to the units, the meters, so we got to go over 1, 2, 3 to the right. So this one here, 1, 2, 3 to the right. So that is going to be 430,000 meters. Okay, so to find that volume, it's really just a big rectangular prism. So it's going to be 5 times 1 times 430,000. Okay, so let's see what that gives us. So 5 times 1, we don't really need to do the times 1, do we? Times 430,000. Is that the right number? Yep. Push enter and we get that. It is 2,150,000 cubic meters to make that wall. If you'll notice here, we have 2,580,000. So that, excuse me, is so this, the volume of this pyramid is more than enough to make the volume of this, this wall. Okay. So determine whether Ahmad's claim is correct. So we would go with Ahmad is correct. And it says give a reason. The wall would need this 2,150,000 cubic meters, which is less than the volume of the pyramid. Volume of the pyramid. Okay. That should, I think that should suffice. Okay, that should work us out okay. All right, and don't you worry, there's more to 4. Ahmad and his friends like to sit in the pyramid's shadow, which is this here, ABW, to cool down. At mid-afternoon, BW is 160 meters, which they show us right here. And angle ABW is 15. ABW, this here is 15 degrees. Okay? Calculate the length of AW at mid-afternoon. So A to W. So we're trying to figure out, again, instead of putting X, I'm going to put AW. So we know this side, we know this angle. We also know this side right here, since it's a square base, this has to be 230 meters. Okay? So if you have two sides and the angle in between, we're going to want to use the law of cosines, right? So this is F part 1. So our law of cosines gives us, since we're looking for a side, we want to use the a squared equals b squared plus c squared minus 2bc cosine a. Okay, and really what you can do here, if you kind of panic and say, wait, my a is in the wrong spot, what you can do once you've drawn all your pieces in here, you can reassign these variables here. You don't have to you can cross these all out and say, okay, the angle that I have is A, so you can just say, okay, I'm going to call this A now, and then call either one of those B and C. It doesn't really matter which one is which, so you can say B and C. Okay, so we're going to solve for this side over here. So the side that we're solving for is the AW, so we'd go AW squared equals B, so across from angle B is side B, 160. 160 squared plus across from angle C is side C, 230. Oops, minus 2 times 160 times 230, all times the cosine of the angle that's in between, which is 15. Okay, so then we'll just want to put this into our calculator as well to figure out what AW squared is, at least at first. Okay, so you really, on this one here, you want to put the whole thing in all at once. Don't do part of it and then figure out the other part, because what most people want to do is they want to stop right here, and then that gives you a completely wrong answer. So just put the whole thing in all at once. 160 squared. I'll just put that all in here. Okay, here it is, all entered in just like it looks there. We'll push equal, we'll get a big number-ish here, so we get equals, oh nuts, where did it go? 7407.86 meters, right? Really, this is going to end up being meters squared, isn't it? Because then we got to square root both sides. And we'll do that on our calculator here. So we already have the number in. Don't hit clear and re-enter it. Just do second square root, second answer. Second answer is your friend. I'm hoping that you've got that down by now. But so we end up getting the AW is 86.0689. 86 point. Oops. 0689 is AW. So we want to round it to the third significant digit, right? So we get 86.1 meters is going to be the length of that shadow. Okay. Part 2 on this here says calculate the area of the shadow. So on that one, now we're going to want to use the area of a triangle. If we knew the height here from any one of the bases, we could use area equals 1/2 base times height. But since we don't know that, we're going to want to use our trig, our area of a triangle, our trig stuff. So that one is area equals 1/2. Let me see, what is it? Isn't it BC sine A? Okay, that's also on your formula sheet underneath the trig area. Okay, so area is going to equal, let's put that in our calculator. We got 0.5 times B and C are 160 and 230. 160 times 230, and then sine of the angle is 15. And we get area equals 476.22, 476.22. So our area of ABW is 476 square meters. Okay. Let me double check on here. Yeah, let's see. Oh, you know what? I only hit 23. I gotta redo that. That's won't let me do it. So let's see. 0.5 times. Sorry, the 160 times 230. There we go. I got the 0 in this time. And then sine of 15. 4762. So I was basically just off, the decimal's off by 1. It should be over here. Right? It should be over there. So here, let's do this. 4760, because this decimal really is right in there. And that's going to be meters. And again, this is area, so meters squared. Okay? All right. Let's take a look at our mark scheme and make sure that we are good to go on this. So first one, units are required in part C and F part 2. So hopefully we put those units on there. It's just a good idea to put units on everything. Part A, we did tangent of 58.3 equals VM over 115, and we end up getting 186.2, and we round it to 186 meters, so that's good. Okay, so we're good on that one. Note, both the rounded and unrounded answer must be seen for the final A1 to be awarded. So that's interesting. Both rounded and unrounded answer must be seen. So if we went through and had this, from what I understand here, if you wrote just 186 instead of the 186.200, you would only get 1 point, which is it's a little curious. I'm not a big fan of that, but you know, we'll just go with it. So thankfully on here, if you remember, way up here, we did write 186.2 on there, so I think that would get us. Ooh, you know what it says? Both the rounded and unrounded answer must be seen. So we did have an unrounded answer of 186.2. Hopefully we would get credit for that. I don't know why we wouldn't, but yeah. Anyway, let's move on here. So let's see. Part VO squared plus 115 squared equals 186. We had that, and we ended up getting 146.188. I believe we had. I think actually we just put 146.2, didn't we? 146 point. Ooh, we have 44, and they have 188. Oh, use of full calculator display for VM gives 146.443. Okay, that's good. But we rounded to 146, so we should be okay on that one. Okay. Part C is where we found the volume of our pyramid, 1/3 of 230 squared times our height. And good, we used the 146 point, either we used the 188 or we used 0.2, and we ended up with 2,580,000. So that's good. The answer is 280 meters cubed. The units are required. Let's make sure that we put our units on there. I think we did. I hope we did. There it is, meters cubed. So there's that. Did we show anywhere where we plug that in? Oh yeah, here's our volume. Here's our work for part C, so we should be okay on that. Let's see, we're okay on that. Part D is 2.58 times 10 to the 6 meters cubed. I believe we had that. 2.58 times 10 to the 6. I didn't put the meters cubed on there. I really should. It didn't look like they were going to take points off for that, but it's just better to put that on there so we get all of our points. Okay, so award for 2.58 and 10 to the 6th. Yeah, and that's just if you messed it up, you can get some partial credit. So we didn't, and we're not planning on messing up. So let's go with that. Question 4. Volume of the wall would be 430,000 times 5 times 1. We did that. Get a point for correct substitution of the volume formula. And then we have this, 215, which is less than the volume of the pyramid. Ahmad is correct. That's basically what we had. We actually explained it better, I thought. But that one should be good. Okay, and then let's see. I think that's it, isn't it? Yeah, I think that's it for that question. Right? Wasn't that the last part? Yeah, that's too slow. All right, so we did 86 point. Did we get to that? No, this is the next part, isn't it? Continued. I should have just read. Okay. So for there we go. There's to figure out our missing side. 160 squared plus 230 minus 2 times 160. We did all this, and we got 86.1. Right? There's our 86.1, and we even showed that. So again, apparently it's a good idea to show this number before you round it. So that's a really, that's kind of, on the earlier on there, it took away a point if we didn't show what we rounded from. So I guess it's a good idea to show that. Let's see. So there's that. Trying to think. It looks like we're okay. Correct substitution. We're okay. And then the second part, area is 1/2 230 times 160 times sine 15. We did that and got 4760 square meters. And the units are required, which I'm pretty sure we put that on there, right? Yep, 4760 square meters. All right, that was kind of a long one. I think that's the longest one on here. You'll probably get at least one that's a fairly lengthy one. These last two here are not as lengthy. Let's find that. There it is. Okay, number 5. Antonio and Barbara start work at the same company on the same day. They each earn an annual salary of 8,000 euros during the first year of employment. The company gives them a salary increase following the completion of each year of employment. Antonio is paid using Plan A, and Barbara is paid using Plan B. Okay, so this is Antonio, and this is Barbara. Okay, so Antonio just gets an extra 450 euros each year, and then Barbara, the annual salary increases by 5% each year. Okay, so that's 5% the first year, and then it's 5% of what she earned the second year for the third year, so so forth and so on. All right, so with this here, Antonio's annual salary during his calculate Antonio's annual salary during his second year of employment. I'm liking this question here because you're starting with 8,000 euros and you're going to add 450 for a grand total of 8,450 euros. Excuse me. I tried to pause it, but I missed. Okay. Barbara's annual salary during her second year of employment is going to be increased by 5%. So we're going to do 8,000 times. Now you can multiply this by 5% and then add it to the original 8,000, or the quick way, if you'll remember, is multiply it by 1.05, right? Because that's the 1 is the original 100% of the 8,000 plus an extra 5%. So this is 105% is what she's going to earn in the second year. Okay, so we can enter that in. Okay, so we get 8,000 times 1.05, and we get 8,400 euros. So it's pretty close. It's only off by 50 bucks. 50 euros, excuse me. Okay. Part B, write down an expression for Antonio's annual salary during his nth year of employment. Now, we got to be a little bit careful with this because we got to make sure that we do the right values for N. So the first year of employment, he should make 8,000. So what we like to do is usually say, okay, it's 8,000 plus 450 times, let's see, times N, right? But if we did 800 times 450, plus 450 times N, and N is his first year, that's going to mean he made 8,450 in his first year, which we know is not true. So what you want to do here is do 450 times N minus 1, right? Or what you could do is, you could take 8,000 and subtract 450. Let's see, so if we did 8,000 minus 450, that would give us 7550. So we could do 7550 plus 450 N. Because if you did put 1 in for his first year, 450 plus 7550 is going to get us back to the 8,000. So either one of those works. This is the more universally accepted one, but I think I can't imagine why they wouldn't accept that. Okay, so we could do either one of those. I'm going to stick with this one for now. Okay, Barbara's annual salary during her nth year, again, would be 8,000. And then we're going to multiply that by 1.05. And then that's going to be, you're going to multiply it by 105% for every year. And again, same idea here. If we put N1 in for her first year, that means she's making 8,400, but she only made 8,000 euros the first year. So we would also on this want to put N minus 1. Okay. The other way you could do that is take 8,000 divided by 1.05 and you get some other number, but I think your N minus 1 is going to be your best bet there. Okay. Okay. Now, part C, determine the number of years for which Antonio's annual salary is greater than or equal to Barbara's annual salary. So now basically we have to figure out when these two functions are going to intersect, right? So there's a couple different ways you could do this. You could do it on the graphing calculator, which could get a little tricky because you're going to have to figure out the window. Or we could, take our luck on just making a table. This is 8450 and 8400 is really pretty close. So I would imagine that they're going to intersect pretty soon. So I'm going to take my chances and make a table. And if my table is not getting me anywhere fast, then maybe we'll have to go back and do a graph. But let's try a table. So here's, let's see, let's do Antonio. And then we've got N for the number of years, right? And then this will be his salary, right? So first year, we know he's at 8,000. Second year, he's adding 450. We already did that. That's 8,450. Third year, add 450 to that. A little kind of nice trick on your calculator is do 8,000 plus 450. Push equals, and I believe if we push equals again, it'll keep adding. Nuts. It didn't. Plus 450. Now, now it's answer plus 450. So that gives us 8,900. Okay, and then now on our calculator, when we push enter again, it should add another 450 each time. 9,350. 4, 5, 6, 7. Let's try 8. I don't know, because this is pretty straightforward. This is pretty fast. Equals 9,800. equals 10,250. And again, you want to make sure your handwriting is legible. That could be misconstrued as a 7, so I'm going to make sure that looks like a 9. 10,250. And then 7. I'm just going to do it a couple times. 10700. And then 11,150, I believe was right? Yeah. Okay. So let's see if it happens to intersect. So let's find. This is Barbara, her N, and her salary. So when N is 1, she's at 8,000, right? When, oops, not 800, but 8,000. N is 2, we figured out that she's at 8,400. Okay, so we should be able to do the same thing with the calculator here. We got 8,000 times 1.05 equals 8,400. Now, once you push times, it's going to take now your answer and multiply. We just do 1.05 again, and that gives us 8820. 3, 4, 5, 6, 7, and 8. Let's see if that gets us there. Now, again, each time we push enter, it should get us there. 9261. 9724. I'm just going to round it to the nearest dollar. 9724. Well, you know what? It's this. I might as well put it to the nearest cent. I can do that, or the nearest tenth of a hundredth of a euro. I don't know if they do tenths. 102.1025. 102.1025. 107.20. 0.77, and then we'll do one more for good measure. 11,256.80. Okay, so let's compare. So we've got Antonio she's making more. Again, we're determining the number of years for which Antonio's annual salary is greater than. So it is greater than here at year 1. Actually, it's the same. Says greater than or equal to, so it's okay there. 8450 is okay there. 8900 is more than 8820. But if you'll notice, this was off by 50. This is now off by, gosh, what is that? That's off by more, isn't it? Interesting. But if we look down here, it catches up. So 450. Yeah, that's interesting. I wonder if I wrote that down wrong. I should 8820. No, that's weird. Okay. Anyway, 9350. We're at 9261, so he's still ahead there. 9800, 9724, still ahead there. 10250, 10210. So she's starting to catch up now. And then 10700 and 10720. So now she's ahead here and here. So determine the number of years for which Antonio's annual salary is greater than or equal to Barbara's salary. It's for the first 6 years. He's ahead, and then after that, Barbara makes more. Okay. Both Antonio and Barbara plan to work at the company for a total of 15 years. Calculate the total amount Barbara will be paid during these 15 years. Okay, so all we have to do now is plug 15 into this for the n, for the number of years, right? So let's do this up here where we've got some more room. Okay, so D part 1, is we're going to do 8,000. Oh man, handwriting's getting bad, sorry. 8,000, there we go, take your time. Times, and it's this one here, 1.05. So let's do 1.05, and it's n to the n minus 1, so it's really 15 minus 1, so it's just to the 14th power, right? So we can do 8,000 times 1.05 to the 14th power. And at that point, she's going to make 15,839.45. 15,839.45. See, calculate the total amount that Barbara will be paid during these 15 years. We would definitely want to write that out, and then now we need to round it off to 3 significant figures, because it doesn't say anything up here about rounding to the nearest dollar, the nearest euro or 1/10 of a euro. So we got to go with 15,800 is going to be euro. That's going to be what Barbara makes. And then D part 2, determine whether Antonio earns more than Barbara during these 15 years. And these 2 questions together is worth 7 points. So we want to make sure that we do well on these. Okay, so let's figure out how much Antonio is going to make, right? So he's this one, 800 plus 450 times n minus 1. Sorry, 8,000. Plus 450 times 15 minus 1. So calculate that out. And we already know the answer to that, right? He's going to make, let's see, is this determined? Oh, the total amount. I got to back up because this was just how much she makes in the 15th year. So I got to, oops, that's not what I wanted to do. Let's go back here. We got to go back. This is all wrong. Sorry. Okay. So we've got to figure out the sum of what she makes. So that's a whole different ball game. See, notice they said, they even bolded it for me and I didn't pay attention. Total amount. Okay. So we've got to figure out, we got to calculate her total amount that she makes over these years. So this is going to be the sum formula. Okay, let's see, for her it's the geometric term, right? Because you're multiplying by the same number over and over and over again, right? So that geometric sum is on your formula sheet, and it's going to say this one here, S of n equals, here, let me find it first. Okay, here it is. We've got our sum of, we want the geometric sequence. So it's going to be either this or this, not both. Just enter one or the other. I don't really know why they have both of these. It's not, one is not necessarily nicer than the other. I'm just going to use the first one here. So we've got S of n, and it doesn't specify on here, so you're going to need to know that U sub 1 stands for the first term, n stands for the number of terms, and it doesn't have it in here, but U sub n is the last term. Okay, and then up here for the arithmetic, which we'll use in a little bit because we have to figure out Antonio's total too. The D is the difference, but we'll get that when we get there. So we have this little formula here. Let's copy that over. Okay, so here we go. We've got our formula. So the sum of the first 15 years for her is going to equal U sub 1, the first term, which is the first year, 8,000, times R is the rate, and that's our that's going to be our 1.05. That's our growth rate. So we do 1.05 to the n, which is the number of years. So in this case is 15 minus 1. Don't worry about the n minus 1. This is a different formula. All divided by the rate, 1.05 minus 1. Okay, so now we want to calculate that out there. Okay, so we're going to do 8,000 parentheses 1.05 to the 15th. And then, let's see, minus 1. We should be okay on that. Okay, so we close that. That's going to give us this. So we get 8631. And then we got to divide it by 1.05 minus 1. So let's do this. Divide. You can either figure this out ahead of time, but look, 1.05 minus 1 is just going to be divided by 0.05. So divide by 0.05, and we get that she makes a lot of money, 172,000. So we get 172,628. Let's do 172,628 euros. Right? Is that our actually it's 29 if we rounded that, but we're going to just round this number anyway. So it's going to be 173,000 euros is how much she makes, right? Because we got to round to the to 3 significant figures. So then part 2 is going to be determine whether Antonio earns more than Barbara during these 15 years. So now we're going to have to figure out how much Antonio makes. Of course, we don't have enough room down there, so let's do this down here. So let's go back to our formula sheet, and now it's when you're adding the same amount each time, it's the arithmetic, and you're just adding 450 each time. Barbara, you were multiplying by a number each time, and that's geometric. So hopefully you'll remember that. So we're going to use the arithmetic, and you can use either one of these two. Again, this is the one if you know what the last term is, which we don't. This is if you know what the difference is, which we do. So let's use this formula here. I'll copy that over. Okay, there's our formula. So the sum of his first 15 years is going to be n, the number of terms, 15 years, 15 over 2, all times twice the initial value. His initial salary is $8,000, 8,000 euros. Sorry, I keep saying dollars. Plus n, number of terms, which is 15 minus 1, all times the difference. So that's how much it's going up by each year, and that's our 450, right? Okay, so now we're just going to put that into our calculator and see what that gives us. So we've got 15 divided by 2, and then we take, let's see. Let's just do this. 7.5 parentheses 2 times 8,000. Again, if you put this in just as it looks, we should be a-okay. Plus another parentheses 15 minus 1. We can just put 14 in there, and then 450. Close our parentheses, and he makes 167,250. 167,250 euros, right? The sum of his first 15 years, which we would then round to 167,000 euros. Okay, so it says determine whether Antonio earns more than Barbara during these 15 years. So we would say nope. He earns less than Barbara. They didn't ask for it, but it's a pretty simple calculation where we could say, let's see, she earned 173,000 euros, so 173 minus 67, so he earned 6,000 euros less over 15 years. Okay, let's check our mark scheme to see how we did on this one. Okay, first one, 8450 euro. We got that one. 8,000 times 1.05 was 8,400 euro. So it says award M1. So your method 8,000 times 1.05 or 8,000 times 0.05 plus 8,000. We did this one, so they want to see that, which we showed on there. So that's good. We're good on those. Part B, 8,000 plus 450 times n minus 1. And there, look, there's our n minus 1. And look, here's the other option too, 450n plus 7550. I think that's what we had, wasn't it? That was the other. Yeah, there it is, 7550 plus 450n. I really think our best bet is doing the n minus 1. Okay, you can always double check to see if your formula is working by plugging in 1 for the first term and make sure that was the first year, and we would say, oh wait, we're $450 too much, so just subtract 1 from that and we're good. Okay, corrects award 1 point for substitution in the arithmetic sequence formula and 1 for correct substitutions. Let's see, arithmetic sequence formula. Let's take a look at that. Well, looky there. There's the arithmetic sequence. So there's just saying you could have just plugged it straight into this formula, right? U sub 1, so that's 8,000 plus number of terms, n minus 1, all times the difference, which is 450. Okay, so that's really what we had. We had 8,000 plus 450 times n minus 1, right? 8,000 plus 450 times n minus 1. So instead of even having to come up with it yourself, just plug it into, this arithmetic sequence. The nth term of the arithmetic sequence. You can just plug that straight in. 450 is the difference, 8,000 is the first term, and then n is the number of terms. You just leave the n as n. Okay, and that would give us the formula. So that's a little bit easier way to do it. Let's go back to our stuff here, our answers. So next one, 8,000 plus 450 times n minus. Okay, we did that one. And then for part 2 is Barbara's amount. So there's 8,000. Oh man, geometric sequence formula. Look at that. It's probably gonna. Here's the nth term of geometric. First term times the rate, 1.05 to the n minus 1. So look at that. You can just plug those straight into the geometric and arithmetic sequence formulas. That makes it easier, doesn't it? Okay, so plugged it in, got this, so we're okay. Or at least 4 correct terms of each sequence. So they're just saying if you just went through and actually added them all up or multiplied them up. So that's fairly easy there too, but you'd have to do that for the last problem. You'd have to do it 15 times. There's a good chance if you did that 15 times, you'd end up with a wrong number somewhere or another in there. Okay, so award a point for correct lists corresponding to their answers for parts B1 and B2. Okay, so that's where we did our list. Sorry, that's this one. Here's our list, and they're saying as long as we had four pieces listed on there, then we would have been fine. So we could have started at 3 or something like that, but that wouldn't make much sense. A lot easier to do this. So this chart here, these 2 lists are going to get us credit for that. Okay, value must be an integer, which we have. Follow through from parts B1 and B2. Award G1 for a final answer of 6.70018 seen without working. I'm not sure what that even means. Because look, if you get the 6, you get all 3 of your points here. So I'm not sure what this is. Oh, you would only get, instead of getting 2 points, you would only get 1 point if you had 6.7008. So I'm not sure where that number would have came from, but we didn't get that, so we're okay. And moving on down to the next one, part D. This is where we found our sum of the first 15 terms of the sequence, 8,000. We did all of this. 15, 8, 39, 45. I believe we hopefully had something like that. Oh, you know what? They just found Barbara's last year, which we didn't even need to do. Let's see. This. So we did this, and they said, or you can do this and then figure out the other formula, but we didn't. We don't have to do that because we used this formula and we got 173,000 euro. So that's good. Okay. Part 2, we substituted into that formula. Right. We substituted into this one here, and we ended up getting 167,000 euro, so that's good. 1 point for correct substitution into the arithmetic series formula, which we did. And 1 for correct substitution using first and last term from the other part. We got that. And then Antonio does not earn more than Barbara. His total salary will be less than Barbara. So either one of those they would have taken. So we put Antonio does not earn. We did something like that, right? Let's see, what did we write? No, he earns less than Barbara. I think that should be fine. His total salary will be less than Barbara, so that should be good. Okay. Except Barbara earns more. And then we just had he earned less, so we should be fine on that one. And then, the final A1 can only be awarded if 2 salaries are seen. So thankfully we, on this, showed both salaries, right? We had the 167,000 euros and the 173,000 euros. So we showed both of those. So we should be good on all those points there. All right, and I think that takes us to the last one. It does. Okay, let's look at the last one, and away we go. Number 6. Okay, so function f is given by this here. Calculate f of 0. So basically, you're just, if that's f of x, f of 0, we're just plugging 0 in for that, right? So let's do 4 times 2 to the negative 0 plus 1.5 times 0 minus 5. Okay, so 2 to the 0, anything to the 0 power is positive 0 or negative 0 is going to end up being 1. Hopefully you remember that. So this is really going to be 4 times 1 plus 1.5 times 0 is 0 minus 5. So really we have 4 minus 5, which gives us negative 1 for the f of 0. So calculate f of 0. So let's do f of 0 equals negative 1 for our final answer. Okay. Let's see, moving on. Use your graphics display calculator to solve f of x equals 0. So let's put that in. So we're basically just going to want to graph this thing here and find out when f of x equals 0. So it's 0 equals all of this. So really we're just putting in this formula here into our graphing calculator, and if you'll remember, use your graphing to solve. Whenever they're asking for you to solve, they want to know what the x values are. They don't care about the y, they just want to know what the x values are. Okay, so let's put this formula here into our y equals. Okay, so clear out anything else that you might have in there, and let's enter this in. Okay, I put it all in here already. And it's really important here with this 2 to the negative x. So 2 to the negative x, you got to push this negative number, this negative sign here instead of the subtraction sign. So notice that's the negative and that's the subtraction. Okay, so make sure you do those. Now, who knows what this is going to look like? So let's just do zoom standard and hope that it shows up. Okay, so oh, hallelujah, look at that. There's our graph. Okay, so use your graphics display calculator to solve f of x equals 0. So now remember, in the directions it specifically says anytime you're using your graphing calculator to find solutions, you need to draw a sketch. Okay, so what we need to do is we need to sketch this thing here. Let's do this first. Let's find our solutions. First. So hopefully you remember, well, f of x equals 0, that's when y equals 0. So that's just going to be our that's when y equals 0, that's our two x-intercepts. So we got to find out when that crosses there and where that crosses there. So we're going to go into second, calculate, and we want to find when it intersects the x-axis. So intersect, back up. That's when we have two intersecting lines. We want to find the zeros, right? So that's when, and look at that, f of x equals 0. So that's why they call it, well, that's part of the reason why they call it zeros. So we want to get to the left of where it crosses the x-axis, enter, and then move over here to make sure that we're to the right of where it crosses, enter, and then enter one more time, and we get x equals negative 0.5376. So it's negative negative 0.538 is one of them. Negative 0.5, oops, that's supposed to be a 3, but it does not look like a 3. 3, 8. And there's going to be another one, and that is over here. So we do second, calculate, and again we want to find the zeros, and then now we move it over here, and it says basically this left bound means go to the left before it crosses through the x-axis. So we would do enter, and then now we have to be right bound. So this is after it crosses through, to the right of where it crosses through. And now these two little arrows are going to say, okay, we're going to find when this thing crosses through the x-axis. Basically what it does is it's looking for a sign change. Okay, so we push enter, and that gives us that x is equals 3. So we get negative 0.538 and 3 are going to be our two solutions, right? Solutions, they just want to know what the x's are. Okay, so let's see. We did this, and then it actually is asking us to sketch a graph for this, which is interesting because it says use your graphics display calculator to solve this. So normally when you are using your graphing calculator to find graphs, to find solutions, you have to sketch it anyway, but maybe they're just being nice and having you sketch it anyway. So let's see, x has got to be between negative 2 and 6. So let's draw ourselves a nice graph here. So negative 2 and 6. So let's make our y-axis here. Let's see, y is going to be between negative 4 and 10. So let's go. Ooh, here I'm going to just have to do. Oh, that's not it. There we go. I'll get there. Don't mind me. So why is this not working? Sorry. Let's try this. Let me fix this. Just turned my pen off, sorry. Okay, so let's make that y. So always label your x and y axes. So that's y, that's x. And it says that we want x between negative 2 and 6. So there's, say, negative 2. And there's 1, 2, maybe even label these 3, 4, 5, 6. And then we want the y's to go from negative 4. So let's see, we'll go 1, negative 2, negative 4. Try to keep this as consistent as you can. It looks like I didn't make it quite big enough. 2, 4, 6, 8. I'm sure you're entertained by me counting out loud. Sorry. Here's 10. So let's get rid of that and put that y up here a little farther. Okay, so there's our nice scaled axes there. And then now we want to sketch our graph. So we know that it crosses through at negative 0.538. So we'll just call that right there. And then also crosses through at 3. Okay, so looking back at our calculator here, that's down a little bit above 2 and a little bit before 1 is the minimum. Okay, so like about right here is our minimum, and I don't believe we will have to put that minimum in there. We should just be able to leave it like that. And then now they want us to, they want to see what the sketch is going to look like. So there's negative 2, starts up here at about 4, 5, 6, 7, about 7 or so. Again, I don't think they're going to nitpick that much on us since it says sketch. So we want to do this. Comes down and hits that. And then it's coming back up through here. And then over at 6, 1, 2, 3, 4, 5, 6, we're at about 4 or 5, something in there. So we want to end up over about here. So something like that. That should be a decent enough sketch for them. Okay. Showing x and y intercepts. Ooh, y-intercept. That's interesting. It says show that y-intercept. It didn't ask us for that earlier, but you know what? We can find that. So let's do second calculate, and all we need to do now is find the value. We want to know when x equals 0. When x equals 0, y equals negative 1. And look at that. Just so happens that we put it right through there at negative 1. So we lucked out there. X and y intercepts use a scale of 2 centimeters to represent 2 units. Ooh, so we would not want to have all these extra slashes in between. I should have read the whole directions first. So we would only want the lines that we actually have the numbers on. I'm not going to erase them all, but basically what they're saying is they don't want these extra lines here. Okay, so I'm going to leave them on there for now. But if I was actually doing the test, I would have fixed that. Okay, so now we sketched the graph. That's part C. That's a 4-pointer. So we want to do a good job with that. Doesn't say anything about finding the minimum. We just kind of put a point there as to roughly where it's at. Function f is the derivative of a function g, and it's known that g of 1 equals 3. Calculate g prime of 1. Okay, so now we got this derivative business. So this is not really the best worded problem in here, but they're saying that this function f here, this function, is the derivative of g. So calculate g prime of 1. So g prime is the same thing as f. So basically all we're doing right now is just plugging 1 into this function here. So f of 1 is going to equal 4 times 2 to the negative first plus 1.5 times 1 minus 5. Okay, so just to make sure and safe, let's plug this into our calculator. 4 times 2 to the negative first plus 1.5 times 1. I'm just going to do plus 1.5 and then minus 5. That gives us negative 1.5. So f of 1 equals negative 1.5. Okay, and then last one, find the equation of the tangent to the graph of y equals g of x at x equals 1. Give your answer in this y equals mx plus c. We're used to seeing y equals mx plus b. Okay, so again, another little bit of a confusing question here. Find the equation of the tangent to the graph of y equals g of x at x equals 1. So this is the derivative function, the derivative of g, and we already plugged in 1. So remember, when you find the derivative of a function and then you plug a number in, that's telling you the slope of the tangent at that point. And that's what they're, this is going to actually be really helpful, because that slope, that negative 1.5 is the slope of this one here. So we really have negative 1.5 is going to go in for our slope. Okay, and then we also have this here, this g of 1 equals 3. So we know that when x is 1, y is 3. So let's plug in 3 for y. 3 equals 1.5 times x is 1 plus c. So we get 3 equals, equals negative 1.5 plus c. Add 1.5. And we get 4.5 equals our c. So then that means our equation is going to be y equals m, which we figured out was negative 1.5 x plus c, which is 4.5. And that's our equation of the tangent at x equals 1. So that line there is the tangent line to the original g of x graph. Okay, all right. Let's check our mark scheme to see how we did. So number 6, part A, 4 times 2 to the negative 0 plus 1.5 to the 0. Award a point for substitution, and then we end up getting negative 1. So there's our other point. Okay, so we're good on that. B, we got negative 0.538, I believe. Yep, there's our negative 0.538, and 3. So there's our 2 intercepts there. Okay. Oh, look at that. Award at most. You're going to lose a point if you give this as the x and a y and an x and a y. So like if you did negative 0.538 comma 0 and 3 comma 0, you would lose a point. So remember, on here, on the question, whenever they're saying solve, that means x only. Don't give the y when they ask you to solve. Okay, so moving along here. Here's our graph, our sketch of our graph. They've got theirs going all the way up there. Ours is not quite all the way up to, oh wait, I think it was up to about 8, wasn't it? Let's go back and look at our beautiful graph. It's pretty close. We did it to about 7. And then that one goes up to about 4 or 5. Let's see how nitpicky they're going to get on us on this one here. So award A1 for labels. There's our labels, X. and y, we had those, and some indication of scale in the correct given window, which we did. Award A1 for a smooth curve. My curve is not very smooth. You'll want to try to make your curve look smooth, because with correct general shape. I imagine they're going to cut you a little slack here, because that's fairly smooth, but there's some goofy little spots in there too. So anyway, I think you'll be okay on that. And starting with f of -2 up to 6. So there's our -2 to 6, and that's what we showed on our scales here. Minimum to the right of the y-axis. We're okay on that. 1 point for correct y-intercept, which we did at -1, consistent with their part A. And then another point for approximately the correct x-intercepts. So we have our correct intercepts. We had our correct intercepts there as well. 1, 0 between -1 and 0. So basically, if you're somewhere in there, they gave you credit, and then the other one between 2.5 and 3.5. So as long as you're in the neighborhood, they're giving you credit for that. Okay, and then D, G prime of 1. So look there, we did exactly what they did. We just plugged 1 in for the x, and we got -1.5, which we got. And then for the last one, we plugged in -1.5 for the slope, 3 for the y, 1 for the x, and we solved for c, and we got y equals -1.5 x plus 4.5. Okay. So you get 1 point for just showing this here, and then you get another point for getting your correct answer there. All right, that is it for paper 2. If you have any other questions on this, please feel free to ask in class. All right, thanks.